in the last example, I showed you a typical calculation of elasticity, and these, that's just really common. There's going to be one other technical skill I'm going to ask of you this unit in tomorrow's class, Tuesday's class, and that's going to be to calculate elasticity when all you have is a point along a straight line, and so that's what this one's going to be about. Let's go forward. I've got a straight line demand curve, and I've got this nice arrow that's the color of a green at a golf course, close anyway. Anyway, let's suppose we knew that price was $20 a round and that the quantity of rounds demanded at that price was 768. And let's suppose that we knew that point was along a line that had a slope of negative 159. Actually, that's the slope that was implied by that example in the last screencast. Price went up by 2, quantity demanded went down by 118. 2 over 118, negative 2 over 118 is the same as negative 1 over 59. Anyway, so we have it in this form instead. Well, what do we do? Here's what we do. We first recall that our formula for the elasticity of demand can be written as delta QD, the incremental change in the quantity demanded, divided by the level of quantity demanded, all that fraction divided by another fraction, the incremental change in price over the level of price. And with some fairly simple algebra, I'll leave you to show it at home. And indeed, I'm not going to ever ask you for this derivation, though it's not particularly hard if you prefer to think in terms of derivations as I do. Just trace it out at home, and it's easier to remember that for somebody like me than it is to remember the final formula. But all I'll ever ask you to do is to remember the final formula. Anyway, that we can rewrite that expression as delta QD over delta P, that quantity times P over Q. All right, well, so far so good. What does that have to do with calculating elasticity when you have a straight line? Well, check it out. It turns out, back to my little pointer, this delta QD over delta P is the reciprocal of the slope of this line. We have P as our dependent variable, Q as our independent variable. The slope, rise over run, delta P over delta QD, is this negative 159. So delta QD over delta P is 1 over that slope. And this is always going to be true for a straight line demand curve. So here's the formula. We can rewrite our demand, our expression for the elasticity of demand as 1 over the slope of a straight line demand curve that's written in this form where price is the dependent variable. It's just 1 over the slope times whatever the level of price is that we're talking about, divided by whatever the level of quantity we're talking about. So we can just plug numbers. We have the slope, it's negative 1 over 59. We know P, that's 20. And we know Q, that's 768. So we can just start plugging numbers here. And indeed, anytime you have a straight line in one point, you can just start plugging numbers. 1 over 59 is the reciprocal of negative 59. The reciprocal of negative 1 over 59 is just negative 59. So 1 over the slope turns out to be just negative 59. Then we can multiply that times our price, which is 20, and we can divide that by our quantity, which is 768. And there we have it. And when we do the math there, what do we get? Let me pop that into my calculator. I actually already did this. We get 1.536, which was exactly the same as what we had before. Sometimes you'll get a little different number. Let's say we had some big big price change. I don't even know what this would be. And big quantity change. Notice in that case, the elasticity we calculate by, the method I showed you last, Q1 minus Q naught divided by Q, all that over, divided by Q naught, all that over P1 minus P naught, all that divided by P naught, that whole mess. We'd be estimating the elasticity over a range along the demand curve. But this way of doing it with the point slope just gets you the elasticity right here at this single point. So the elasticity of over this big range will be different than the elasticity just at this point. So if you get a different number by the point slope method than the usual incremental change in quantity divided by the level of quantity, that whole thing divided by the incremental change in price divided by the level of price. Sounds like a bear, but remember, it's just the ratio of two proportionate changes, and you know how to do each one, and you know how to take a ratio. Anyway, sometimes you'll get a different number. Don't worry about that. It's actually the point slope one is far more precise than the one you calculate that other way.
Made with Doodlecast Pro.